integration. Now, there are two branches of calculus. One of them is differentiation, which we have been looking at in previous videos, and the other is integration. Now, integration reverses differentiation. So when you differentiate a function, you get a certain answer. When you integrate the answer, you get back the original function. Now, when you integrate, what you get is called the antiderivative. Because when you differentiate, you get the derivative. When you differentiate a function, what you get is called the derivative. When you integrate a function, what you get is the antiderivative, because it reverses differentiation. Now, you remember that when you differentiate, the new function you get is the derivative. But when you integrate, the new function that you get is called the integrand. Alright? Now, let us start out by looking at the power rule. You remember what happened when you differentiated using the power rule. Let us say you have y equals x raised to a power of n. Now you differentiate, you say the derivative of y with respect to x, that's dy by dx. So you consider x and y as the variables. Dy by dx equals, and in fact, you might have a number that multiplies x. So let me put that in. You have y equal a x to the n. Now, a is a constant because you are considering x and y as the variables. The derivative of y with respect to x is equal to, remember what you do? You multiply by the power n times ax to the, then you get the new power by subtracting 1 from the old power. So that's what you get. Now, let us imagine that you have na to the nax to the n minus 1. You have that function and you want to integrate it. The symbol for integration looks like this. Alright? And then you want to integrate considering x as the variable, not n, not a. You consider n and a as just constants. To show that x is the variable, we put dx. Alright? So this is the integral of nax to the n minus 1 dx. Now, what is that? What you do is the reverse. Remember, when you differentiated, you first multiplied by the old power, then you reduce the old power by 1 to get the new power. Alright? So, when you differentiated, you multiply by the power. Right? That's the first thing you did. Then second, what you did was reduce power by 1. Now, you're going to go in the opposite direction. You ended up differentiation by reducing the power by 1. What you will do is increase the power by 1 now. And you do that first. All right, so you don't reduce now, you increase, and you do the second, what you did in second in differentiation, you do it first in integration. So remember, you have n a to the nax to the n minus 1. What you do is increase the power by 1, say plus 1. Then what you do now, instead of multiplying, you divide by the new power. So it's divided by n minus 1 plus 1. Remember, n minus 1 plus 1 is a new power. So what do you end up with now? You have n a x to the, well, negative 1 plus 1 is 0. So what you have is 1. Is n, I mean, is to the n. Divided by negative 1 plus 1 is 0, so you have this over n. But then, n will cancel n. So what you have is ax to the n. You notice that's what you started out with. So you did the reverse of differentiation. Now, there's something else that I'm going to add to this later. It is called the constant of integration. Now, this constant of integration, it usually written as c, sometimes k, but you add it plus, I prefer to use c. Now, we're going to end this video here, but in further videos, we're going to look at the significance of this c and why it is there. All right? So, I will see you in the next video.